Hello. Good morning, good afternoon, good evening, wherever you're joining me from. This is Jim McKeith. Welcome to All About Apple ARM. Probably won't leave the webcam on the whole time, but I do like to say hi and let everybody see me. I have this weird green glow because I'm actually running on the Apple M1 desktop and using a different software stack for the camera than I usually do, and it leaves this green glow. But at the end, I do have some pre-recorded demos, and if we need to, I'm happy to bring up stuff and do demos live. Yeah, I'm excited. I'm gonna do a poll. Do you own an Apple ARM desktop? It looks like a number of you, about a quarter of you, have an M1, which is a great place to be. I have an M1. That's what all the stuff I'm doing today is on the M1. A good chunk of you have the Pro, Max, or Ultra. A number of you don't really want one. So I guess you can maybe, I'm not here to try to convince you. I'm just here to I'm not a salesperson. I'm not. I'm excited. I get excited. I love telling people about stuff. And I might come across as a salesperson, but I'm not. If you do at the end of the day, or, oh my goodness, this is exciting, awesome, but I'm not getting kickbacks from Apple. And about half of you, not yet, but soon. So cool. The M2 just came out. Actually, I have an M2 MacBook Air coming. That's pretty good price for a laptop. So I'm excited about that, actually. I was hoping to get here before this. And yeah, so that's a good one. If you haven't got one yet, that might be one to think about. Otherwise, the M1 Mac Mini is good. And then I just like to see where you're at, what version of Delphi, C++ or Red Studio you're using. Most stuff I'm going to talk about here is 11.2 type. I guess I should say 11.0. It's for Alexandria. So the Alexandria one would be any Alexandria 11, 11.0, 11.1, 11.2. But if you're not on 11.2 yet, update. It's great stuff. But the last stuff I'm talking about is related to Alexandria. Cool. Looks like most of you are on Alexandria. Awesome. A few of you have no Delphi or other versions of Delphi. And you know what? That's fine if you're not on Delphi. 90% of the content here is not Delphi specific, but I do talk about Delphi, some Delphi specifics too. If you've not been in any of my webinars before, I just love technology and I love sharing stuff, and always excited to get a chance to just tell people about stuff I think is cool. And that's what 90% of today's is. So let me go ahead and start my slides and share my screen. All right. You should see my slides now. So is Jim doing his Space Ghost thing? I guess sort of, kind of. Also have a 27-inch iMac, need a bigger desk. Oh my goodness, yeah, no kidding. I need bigger desk too, but my bigger desk is for multiple computers. I'm gonna go ahead and turn my webcam off. I will probably still gesture to the screen or to the camera because that's what I do. All about Apple ARM. The blog post is all about Apple ARM on the desktop, and most of this is desktop related, but some of it is going to be on the iPad Air, which now has an M1 chip in it, which is cool. They're putting a desktop processor in the iPad. So yeah, quick agenda. I do have some demonstrations at the end, and I'm can be here for a while if we need to do some more, answer questions and do some more demos and try stuff on the fly too. The slides are all available in the handout section. I probably won't read most of these. I'll just highlight some of them. And there's actually more slides in the handout than there are in here, just because some of it's replicated in the demos I'm going to do. So ARM is an acronym for Advanced Risk Instruction Set Computer. So it's an acronym with an acronym in it. If you look about CPU architecture, there's CISC, complex instruction set, and RISC, complex instruction set. There's also the RISC-V processor, which is another exciting processor that's going on, but ARM is a RISC processor, and ARM stands for Advanced RISC Machine, or Advanced Reduced Instruction Set Computer Machine, whereas x86s are CISC. I thought this was a great picture, and I meant to put the credits for that. I'll try to see if we can add that on the blog post, but there's a Ryzen 3 3300X compared to an Apple M1 Max, which the M1 Max is one of the beefier of the Apple processors, but it's pretty amazing to see how much bigger that is. One of the biggest difference between ARM in general and x86 processors is Intel and AMD are the only manufacturers of Intel and AMD processors, and all of those processors are generally compatible. The interesting note, actually, if you go back to when we went from the 32-bit to 64-bit transition, Intel came up with Itanium, which was their own 64-bit instruction set that wasn't backwards compatible, whereas AMD came up with their AMD 64. And for a while, we had both options available, but Itanium ended up losing off, and Intel adopted AMD's 64-bit implementation. And since then, they've expanded on it. While Intel was the originator of the x86, and there's an interesting history about why they licensed it to AMD, they actually had licensed to some others as well. Generally, AMD's and Intel CPUs are compatible. They're both introducing new instruction sets and making innovations and stuff, but they're backwards compatible. You're not going to end up with the situation generally where one is not going to be incompatible with the other. They might add new features, etc. But ARM, on the other hand, has many manufacturers. So the ARM company, they make a specification and then license that out. And then everybody they license it to can implement the required parts, optional parts, and add their own things to customize it and better improve it. So ARM GPUs are not necessarily compatible. Now, most of the time they are, especially when you're looking at, for example, Android devices. Most of those are compatible. There was an issue with a while back with the Tegra 2 didn't implement the Neon instructions, which were optional at the time, but later in the later version of ARM, the Neon instructions became required. Yeah, occasionally you end up with some incompatibilities, but most of the time on Android, they are compatible. All the devices are compatible. But ARM in general, in the broader sense, is not necessarily compatible, especially when you look at that there are some very low-powered ARM CPU options out there that are designed for very specific fixed purposes. The Arduinos and Raspberry Pi, single board computers, and microcontrollers out there frequently are ARM powered. Most likely, any small appliance in your house has an ARM chip in it. A few other differences here between the two. I will point out that the biggest thing I think here is ARM executes a single instruction per cycle. This is the RISC, all the instructions are the same size, whereas CISC, an instruction could take more than one cycle to execute. So you could have some instructions that are bigger than a single cycle. Anyway, number of differences between the two. It's interesting if you want to dive into it more. There's more out there to read, but yeah, there are a few differences between the two. So let's talk about Apple's ARM processors. Yeah, someone commented, the RISC versus CISC war has been going on for a long time. Yeah, it's been something that's been debated a lot, which is better, RISC and CISC. And I remember back in the day, there were a number of people pushing CISC back before the x86 really had the stranglehold on the desktop. There were a lot of CISC desktops out there. Or one of them, gosh, used a comic from BC, I think it was, character from BC to promote it. I don't remember the details, but that's all I remember. So this is Apple's ARM M1 family. We have the M1 Pro, M1 Max, which you can see is quite a bit bigger, and then the Ultra, which is two M1 Maxes, which is pretty freaking crazy. Here's the M1. It has 16 billion transistors and a number of other features, up to 8 GPU cores, 8 CPU cores, 16-core neural engine, etc. The M1 Pro transistors went up to 33.7 billion. More memory, unified memory. This one thing about this, Apple for a while has been integrating a lot of stuff onto the board, and now they're integrating more and more into the system on a chip as well. Like it or hate it, I'm not a big fan of the fully integrated non-user serviceable systems, but that's where Apple definitely is going now with these. Very little user updatability or reduced repairability too, which I have strong feelings on as well. But anyway, the M1 Ultra is the fusion architecture. It's got the two M1 Maxes combined. If you look at the M1 Max, 114 billion transistors, which brings us to the M2, which was recently introduced as here, which is just slightly bigger than the M1, but has a number of improvements. It is a second generation 5 nanometer. So if you're not familiar, nanometer is the measure of how small the traces can be. And at 5 nanometer, they're actually getting down to where quantum and relativistic effects are kicking in. I have a friend that works in CPU and chip manufacturing and talks about how they have to consider quantum tunneling and stuff like that, because you're getting down really small there. And I believe some people are doing 4 nanometer now. Anyway, M2, 15.8 trillion operations per second and 20 billion transistors. There's a short recap with some dates on here as well as in the devices that they're available in. So about a year ago, less than a year ago, was the M1 was released, and the M2 came out in June, so a few months ago. So Apple's moving fast with releasing these in the new version. You're probably familiar with Moore's law. It states that the number of transistors in cheap CPUs, what is it, doubles every 2 years? Yeah. And transistor count is a measure of complexity, but not the only measure of complexity. And not all CPU manufacturers share their transistor numbers. But if you look up here, this is 50 billion transistors at the top. And so here's AMD EPYC Rome is up there at that. This only goes to 2020. So it has the Apple A12X Bionic here at 10 billion transistors. So you can see where this chart is. It's a little older. Like I said, it doesn't come to the latest date. But here is the Apple Silicon family, the desktop family. The M1 has got 16 billion, 34 billion, so it doubles there. Not quite doubles there, but then this one here is a double because it is literally two of those. But then I thought it was interesting that the M2 is back down here just bigger than the M1, so not quite as big as the M1 Pro. So it's probably a safe bet that we will see an M2 Pro, Max, and Ultra as well, if not a Ultra Pro or Max Ultra or something too, who knows. But yeah, there's just the transistor count graph across the Apple Silicon family. So now one of the things that's new in the latest version, so Yilmaz shared that the RTX 4090 has 76.3 billion transistors, which is a GPU. Those things are freaking huge, crazy. And Roland points out that some of the speed comes from the memory is inside the chip. Yep, exactly. As they're integrating more and more of it together, it does give speed, but it reduces your user serviceability, which is unfortunate. But you take what you can get. What about RISC-V? Is ARM executables compatible with RISC-V? No, they're not. They are different. ARM and RISC-V are different. They're not binary compatible. That's the thing. So how to run iOS apps on Mac, that's the basics of it. It just works. That's kind of Apple's mantra. And there's not a lot to this. It just does its thing. And you just go to the App Store, find it, and go. It doesn't, not all iOS apps are available for Mac. And there was a couple I tried this. That's the one thing I really wanted. It's not available. So yeah, but it is useful. It is useful there as well. So another thing that's new is the new ARM-based iOS simulators. Now, it used to be in the original iOS simulators on Mac was that you compiled an x86 executable and ran that. And so it wasn't actually running the same instructions or the same code, machine code, that it would be running on a iOS device because it was compiled to x86. The new ARM-based Macs is they have the simulator now is an ARM-based simulator, which makes sense because you're running on ARM hardware. And so Delphi has added back the simulator support, which is great because now you're actually able to run the exact code on there. The deploying to macOS was introduced in Delphi 11 Alexandria, whereas the simulator was introduced in 11.2. And if I get my version number slightly off, I apologize. The one thing the simulator is great about is just to try different screens, shapes, and sizes, as well as get screenshots for the App Store, and to make sure you're dealing with notches appropriately in your applications. Let's talk about virtualization. Three big players for virtualization is UTM, Parallels Desktop, and VMware Fusion. The UTM and Parallels Desktop both have Apple Silicon support. VMware Fusion, their ARM support is still in tech preview, and I've not tried it, but from what I've seen, it's still not ready for prime time, so generally not recommended. But UTM and Parallels Desktop are both good solutions, and I'm going to talk about both of those in a little more detail. There's also another one called Virtual Buddy that's out there that looks interesting. That's only for ARM Silicon. Apple actually introduced their own hypervisor, and that takes advantage of that. And I believe Parallels and UTM. But I know UTM does if you're emulating versus simulating, and I think Parallels Desktop does as well. Parallels. This is my choice for running Windows 11, and that is a Windows 10 screenshot there. I apologize. But for running Windows 10 or Windows 11 on Apple, my choice is Parallels. They were the first to support doing this right away. They were out right away. But one thing to note is Windows on Apple Silicon is not officially supported. Now it goes back to Windows does support ARM, but they don't particularly specific unless they've updated it. Last I heard, they hadn't updated to say they officially supported Apple Silicon. So my experience has been that it works, and I see a lot of people using it, and it seems to work good, but just be aware it's not officially supported. And Delphi works on ARM Windows, but again, is not officially supported. So ARM Windows does have a compatibility layer built into it where it translates both 32-bit and 64-bit x86 instructions to ARM instructions and is quite performant. It's great. The Apple Silicon is very fast and very performant, and so you can still get a fairly snappy, fairly responsive system, even running it through a virtual machine and the translation there. The only incompatibility issues I've seen, and there probably are more than I've seen, but are where a program specifically looks at the architecture and says, oh, I don't support this architecture. But that's fairly rare. I do have a demo setting up on Windows 11 on ARM. It's really easy later, but I want to talk about UTM. So UTM is an open source virtualization platform, and it has two options. It has virtualization and emulation. Virtualization is plain virtualization and lets you run ARM OSs on the ARM platform. And UTM actually runs on other platforms too. But the emulation lets you use x86 operating systems on the ARM platform. Now, I want to put a note here, and I think my slides should have been in a different order, but I am not, Ubuntu comes in a number of flavors, and I'm going to be showing Ubuntu, not sure how to pronounce that. It uses the XFCE desktop environment, which is a lot lighter weight, and to probably work fine. It's a heavier desktop environment, but I wanted to go with lighter weight one to minimize the load just because it's not going to be near as performant. But installing and running x86 Linux on 64-bit x86 Linux on UTM VM, it's pretty simple. You just go to mac.getutm.app, and you have to go to mac. Because if you go to just getutm.app, then it takes you to their iOS virtual machine support, which is interesting that you can run a x86 desktop OS on iOS. I haven't tried it with a newer one, but anyway, that is an option. Download it, and you want to create a new virtual machine, and you want to select emulate, which is slower, but lets you run other CPU architectures. And they have a ton of CPU architectures you can choose from when you go down the emulate route, whereas virtualize is your traditional virtual machine route. You're going to want to specify 2 or more CPUs, and then at the end, you want to open the VM settings, go in and turn on, enable force multi-core, and enable balloon device. And I do have some more tips for that as well that will improve performance. And the install is slow, really slow, but once it's done, it's actually fairly usable. I've done a little bit of benchmarking, and I'd like to do some more comparison, but it is usable. After you install, so if you install Ubuntu server, you can use this to switch from Ubuntu server to Ubuntu desktop. But if you didn't, you don't need that line there. Otherwise, you just want to update. You can install the clipboard and directory sharing, which is called Spice here, and that gives you better VM integration between the Linux and host OS. And then for Delphi, I have a script you can go out and check out that makes it easy to get it all set up for Delphi 11.2 development, installs PA server and all the requirements. And then connecting to Delphi is just the same as usual. So now I'm going to go and play some of my samples here, or demonstrations videos that I pre-recorded, answer a few questions while I do that, and then I will do more Q&A and questions. So this is setting up Windows 11 in a parallel virtual machine. Is really easy. This is just a couple minutes because I speed up the boring parts, but here you go. Walk you through installing Windows 11 ARM here, and this is with Parallels Desktop, and it has an option just to get Windows 11 from Microsoft directly. You can do Linux as well as macOS too if you wanted, but we're going to do Windows right now. I'm going to switch it to Pro instead of Home, and I just hit install, and it goes out and grabs all the installation media it needs, and just takes a few minutes. This is actually fairly quick here, the process, but I'm going to go ahead and speed it up so you don't have to watch the whole thing anyway. One thing about this being an automated installation is there's limited options for customizing it, which I've ran into issues about that occasionally, but generally it's a good enough installation for most use cases, I'm sure. And we're done.
naturally sped that up quite a bit, but it's still fairly fast. So make sure you read the license agreement. And it drops us in here into Windows with the Parallels web page displayed, but we can close that. And of course, we'll want to update Windows, which again takes a few minutes to download and install the updates. Depends on how long it's been since they've rolled all the patches into the ISO that was downloaded. And again, I'll speed this up here. If you were paying attention to the clock, you will have noticed that the first installation part took about 6 minutes. A few minutes in there, it was waiting on me as well, so maybe 8 or 10 at most. And this part's going to take another 15 minutes. Here we're rebooting now as well. It's all still sped up. And in total, it's going to take less than 20 minutes to complete the entire installation. And there were quite a few times that it was stopped waiting for me as well. And now we have the Windows 11 ARM version running on our M1 Mac Mini under Parallels.
So I'm going to show UTM Linux installation and setup here. There is more details that will be in the slides and the blog post, but I wanted to show a quick video of this.
Once we have UTM installed, we'll go in here and create a new virtual machine. And we want to emulate because we're using different hardware. Linux, just browse for our ISO. In my case, I'm using Xubuntu, which is the lighter weight version of Ubuntu, lighter weight desktop environment. CPU cores need to be 2 or more. I'm going to go with 4. And I'm also going to turn on hardware OpenGL acceleration. You could change your memory here, but we don't have to because I'm going to turn on Balloon. You could change your storage size as well. And I'm going to specify a shared folder so I can swap files between the two. And it's important to select Open VM settings here so that we can change some settings on the next screen. You can give it a friendly name. And now in the VM settings, we want to come in here to System, turn on Force Multicore, and go to QEMU, turn on Balloon Device, which allows it to dynamically allocate memory. And under Display, we could turn off OpenGL if we wanted to as well. Now, we could go into networking too to change the way the networking works, but for right now, this is actually fine. It defaults to shared, which is local machine, but you can go to bridged, which will be accessible across the network. So we're firing up the virtual machine now, and this is going to take a while to run, but be patient. It will get done, and we'll finish. And it's just a standard Linux installation at this point. After the installation finishes and I ran all the scripts, use NeoFetch here to display some basic system information, and we see we're running the x86 64-bit version of Ubuntu, or Xubuntu as the case may be. And now I'll just launch PA Server and get my IP address. Copy that to the clipboard since I've got clipboard sharing turned on. Jump over to Delphi, add the new platform, Xubuntu, which is technically Ubuntu, 20.04 LTS, Linux 64-bit, and provide the IP address, and in my case, a password. Test it. It looks good. And now we'll go to the SDK manager, and we'll add the Linux SDK, which you'll see it detects it is, in fact, Ubuntu. And I always just say yes to override everything. In this case, I had imported this earlier, so it went a lot quicker. And I have the FMX Linux already installed here, but let's double check to make sure. Yep, there it is installed. So let's make a new multi-device application. And I'm just going to use a blank one here. And let's deploy it to Linux. and hit run. Gotta save it really quick. Jump back to it. It's already deployed and it's running. There it is. And this isn't going to be near as fast as a native x86 machine, but it is plenty fast enough for most testing, especially since you could test it on Windows for a lot of things as well in most use cases.
Answered a few questions here. I did want to comment though about Perry asked about using shortcuts in parallels. Practice, I am a lot better than I was originally, but it's still not ideal. I'm pretty sure you can get a Windows keyboard to use in the Mac VM. There's a number of different things you can tweak about the settings in the virtual machine too, to how the keys map is whether or not the command key maps to the Windows key, or you can switch so the Alt key does. That's personal preference. I actually do it the other way around. I switch the command key to the Alt key, I think, and where most people don't, they go the other direction. But yeah, it's not ideal. But you should be able to get a Windows keyboard to probably get a much better solution. So I'm going to show simulator deploying here, which you may have seen already, but here it goes.
So to deploy to the simulator, I just need to start PA server here on my M1 Mac. And let's get the IP address. There we go, 192.168.174. Got the mobile controls demo here. I'm going to go add platform, iOS simulator. Actually, let's start with the macOS ARM. And we'll check the connection. Yep, connected to the right one. Connection's good to go. And let's deploy it to the macOS ARM. Now, macOS ARM is a new platform added in 11. And there we go. Here, our mobile controls demo is running on the macOS ARM. So that compiled in Windows ARM in a virtual machine. So now let's go and add the simulator. And we'll run it. Now I haven't imported the simulator SDK yet, so it's going to prompt me for that. And it just takes a few minutes to load all this in here. And if there's duplicates, I always tell it to overwrite the existing files. I sped that up for you, and now we will finish the deploy onto the iOS simulator. This is one of the great things about doing this in a virtual machine is that when the simulator launches, it automatically pops me over here to the simulator. Now the simulator takes, again, just a few seconds to boot up, not that long. I will speed it up here for you though, so you don't have to wait. Right now it's using the iPhone SE 3rd generation running iOS 16. And there we go. The mobile controls demo is running on here. And we can rotate the screen to make it easier to see all the controls. And I'm going to say, don't show me this again. And let's switch to a different target. I'm going to go to the, well, let's just do the iPhone 14. The Pro Max is really big, so it makes everything really small on the screen since I've changed my scale for video purposes here. Again, just flips this back over here automatically. Finished booting. And here is our application again, with that notch covering up our controls. Very useful if you want to make sure your the notch isn't covering up something useful.
Okay, so there's a question here, and let me go ahead and just do this right now before I do the last one on iPad deploy before I forget, about whether or not you can do the with parallels how much memory you can do. Where is my screen switch? Window Control Center. GoToWebinar does some weird stuff with window management. Okay, there we go. I lost it again. There we go. And let's see how much memory I have on here. This one has set up with 4 gigs of memory. And I believe I have 16 gigs. I bet you could do 8 gigs of memory. I'm not sure if I've tried that or not. You know what? Let's do this. I will shut this down and modify it with 8 gigs and boot it back up again while the video's running. How's that sound? All right, so I'm gonna go ahead and do the next video, which is the iPad deploying to the M1 iPad Air. And when we get back, I will see if that does 8 gigs.
I've connected my M1 iPad Air to the Mac, and we just go into Delphi, switch to the iOS device, and select the M1 iPad Air, and we'll run it and deploy. It's going to the M1 iPad Air. And switch over to my device. You see here it is, the iPad Air 5th generation with the M1 processor running macOS, or I guess iPadOS 15.7. And here's the mobile controls demo running on it. Just that simple.
So I was looking here, and it does. I was going to bump it up to 6 processors too, just for the heck of it. It does allow up to 12 in the drop down here, and has an auto recommended. And I think it probably uses device ballooning where it can dynamically allocate that. But let's go ahead and try. I'll try 10. I would try 12, except I do have the UTM VM running here already, and don't want to make my system totally fail since I'm running the webinar on this platform too. But you know what? I will go for 10 and see where that goes. Let's see, questions here, other questions coming in. I'm using the iPad Air actually to extend my desktop right now, which is useful, but it's not 100%, which is crazy because this is a brand new iPad Air. I would have thought it would have worked great. I would recommend, I think 4 gigs is good, but you're probably going to want to go with more. So there's 10. I just used 10 in here, and let's see if I can. About 6 gigs and 10 or 6 processors and 10 gigs of RAM. So I don't need to blur that out because I didn't put it in there. I'm not sure where that number comes from. And if I reboot it, probably reinstall it, either go away or it'll always be the same. I would say 4 gigs is minimum recommended, Mauricio, but Michael says his is working fine with 8 gigs in parallels. Great. So I know some people that still use Delphi in 1 processor VMs, and I would not recommend that. You want to always have at least 2 processors. I would say 4 is a good number, 4 processors, and then 6 gigs of RAM, 8 gigs of RAM probably be a good number. It depends on what you're doing in there. It does have some dynamic memory allocation, I believe, and I can't know if that does on Parallels or not, but you can experiment with and see. I would definitely get 16 gig Mac that would run it. Let's see, I intend to buy a new iPad into your January. Would recommend getting the M1 iPad. The M1 iPad, so I have not looked at the brand new iPads that just came out, but they don't work with the new Apple Pencil for some reason. They work with the old Apple Pencil. So this one works with the new Apple Pencil, which I intend to do some experiments accessing from Delphi. So I would recommend that one over the new ones possibly. Like I said, I haven't really looked at them yet. But end of year January is a few months away. I'm probably not going to release, since Apple just released the new iPads, which I can't remember which ones those models are called. I read about it, but I'm totally spacing it right now. They're probably not going to release anything new between now and then. It's hard to recommend. It depends on what you're going to use it for. iOS Simulator Emulate Interface not working with Fire Deck. Oh, I think there was an update. Patch for that. I think there's a patch for that. I don't recall offhand. I apologize. So Terry's asking if I've experienced a MS build error under Parallels. I have not. Everything has worked, including Android deployment from Delphi in under Parallels on ARM. So I have not seen that. Do file a bug on quality or search to see if there is one already. That would be my recommendation. I do like my iPad Air. It's actually decent sized. I was afraid it'd be, I expected the iPad Air to be a lot smaller, but it's the size of the original iPads, I feel like. It's not the, what is it? They make the iPad mini, which is the small iPad. This is not a small iPad. It's a larger, it's a full size iPad. They make the iPad Pro now, but iPad Air is a good middle ground. It's nice. I like it. Okay, if there are any other questions or things you want to see working or not working or try, I am happy to do that here. I was actually worried I was going to go over on time, which ironically, when I feel like I have too much content, I scale it back a little bit, and then I usually end up having too little. I can't seem to get it quite right, but hopefully that was good. I got to cover the stuff I wanted to get covered for sure. That's always a good thing. Oh, so the question here from Goran, can you choose iOS version? Honestly, I don't recall for sure. Let's check real quick and see. And I'll put the link in the chat if anybody missed it as well here. iOS device target. Oops, I don't have it running. Oh, I don't have it running. Did have things set up to be automatic, but then I always am updating things and always breaking it. Okay, target iPad Air. Nope, I want simulator. There's simulator. Refresh. Well, those are all iOS 16. There's a way to do this. I don't recall what it is offhand. Let me see something here. A couple more questions came in. So the question, any plan on supporting Linux on ARM? I would love to see Linux on ARM, and I'm always pushing for Linux on ARM, but there is nothing on the roadmap yet. It's something that we talk about a lot, and there's a lot of interest in that, but there is nothing official, no official plans yet. I had not, or running Delphi. Yeah, so that's a good point, actually, Terry. Running Delphi on ARM is not officially supported. Running the IDE Rad Studio in ARM Windows is not officially supported. But go ahead and file the bug anyway. It may get flagged as not getting fixed, but it's good to capture that information. And there's a lot of the people out there in Quality Portal that may have seen it and been like, oh yeah, it's easy to fix, this is what you do. So you never know. Where's the simulator? You've got too many things going here. Oh, I didn't select simulator as a target. Oops, my bad. Let's try again. I must have deployed it. Who knows where I deployed it? I deployed it to my Mac or my iPad, and it just, and I lost my chat window. That's all right. So here's the running the question window popped up here. I'm not sure how it's gonna, let me slide this over here. There we go. I think so. If I go into, it didn't deploy. Once the simulator's up, though, it is quicker to deploy on there. So is there a way in here to go? Actually, you know what? I think it is in Xcode. You remember that Windows Vista commercial where they're like making fun, or Apple commercial, they're making fun of Vista for always asking you to confirm everything you want to do. Apple thought that was a good idea, and they've added that now. Devices and simulator. I think I can go in here to simulators, and I can add a new simulator. Yeah, old version, and we'll say iPhone 4S. I don't think I can download something for that. There we go. Download more simulator runtimes. iOS. Yeah, so you have to download the older versions. And once you download the other older versions and set them up in here, then you can deploy to them from Delphi. So yes, you can, and that's the process for doing it. I'm not going to go through downloading all those questions. Are there any plans to support Apple Watch and Apple TV? So that's actually an interesting question. There is not any official plans for that. But the problem is that the deployment to, and I realize there are technical solutions, but I'll explain the problem. And if at some point there is enough demand, it's possible that we'll still support it. But the problem is that when you deploy to iOS, you actually provide the ARM executable when going into the App Store. For Watch and TV, you don't. You actually provide the bytecode, which is the intermediate representation. I can't remember what the exact term is, but it's not the actual finished compiled. And so we'd have to modify the compiler to spit out the intermediate content instead of the final content. Now, that being said, if you just want to deploy it as a one-off, you can. I know people have done that. I'm not sure exactly what's involved in that. I haven't tried it, but you cannot go to the App Store. So if you take Delphi today, you can deploy to the Apple Watch and Apple TV. I know Apple TV for sure. I'm not sure about Apple Watch for sure. I've heard people doing it to Apple TV. I'm not positive people have done it to the Apple Watch, but you can do that by compiling to it directly or deploying to it directly. But you're not no support for the App Store because you have to have the intermediate representation. And there's not plans for it yet. Again, if there's enough demand, it's possible that will get added, but nothing I've heard for sure. Do you have any Delphi way to change the path in a deployed executable to find third-party Dynalib on a Mac? You can browse around. So there's some folders that are secured. System.io. You'd have to load the Dynalib at runtime, though. Oh gosh, I don't know for sure. To compile for iPhone Pro, do I need a Mac ARM or any Mac will work? But you need the ARM Mac to use the simulator. So any Mac will work. You can have an x86 Mac, and I still have an x86 Mac, and I use it for that. I did a demo with that a while back, and yeah, Carlos is asking if we can upgrade to XE2. So if you buy the current version of Delphi 11.2, it does come with previous version support. I don't know how far back that goes. I would wager it goes back to XE2. I think it does. But you can talk to sales for the details on that. I don't know all the details on that. If I'm using an M1 Pro, Windows 11 ARM and Delphi 11, I failed to install the OEM driver, Android driver. I can't install the APK directly to the mobile. Do I have any tips? Oh gosh, I have not. Oh, because you're trying to use the OEM Android driver? I have not run into that. Does the Android one work? That would be my suggestion. If not, the later versions of Android, I can't remember what version it was, supports wireless Android ADB. I would use that. And I've used that with Delphi and it works great. What C++ builder runs what? At least iOS and Windows apps? I think so. I'm sorry, I don't remember all the details. Let me look real quick. So here is the Windows ARM dev kit. I'll put that link in the chat just because I think it's interesting. Not within the scope of what we're talking about today, but still useful. C++ builder. I think here it shows where it comploys to. Yeah, it does iOS. Yep, so it does support iOS, but not ARM, if I remember correctly. I think it's probably down here at the one. Yeah, 32-bit. Oh, that's for Android. Download the full feature matrix to see. I am really bad at keeping track of all the different versions and stuff. I apologize. Right. William says, at the moment, I need to use install name tool on the Mac to update executable search. Oh, how to modify a dynalib path. I don't know, William, unfortunately. The Delphi Praxis is a great community. You might try checking there. Contact support. Okay, it looks like that's it, and we're just past top of the hour. And I think I got through most of the questions. Are there any plans to support dynamic notification line? I would suspect there is, but I don't know for sure. Now, that being said, I know that you can use other Apple libraries, even including the ones that aren't wrapped by FireMonkey. So there's nothing to stop you, I believe, today from using it and taking advantage of it, but there is not a component or library, currently built into Delphi for that. There may be in the near future. I don't know. I'm not aware of that. But like I said, you can totally, or I would expect you should be able to use that today. People always ask me, does Delphi support X? And the answer is always yes. You can do whatever you want to do. It just depends on, might take a little more effort. Yes, it uses FireMonkey for macOS. Welcome. Any plans for it? All right, great. Thank you so much, everybody, for coming, and appreciate your time. Let's see. I have an app with 1.7 million lines of code using Delphi 11 installed. Oh, okay. So Victor's saying compiling it locally versus over the network takes a lot longer. Don't compile. Do not compile your source code over the network. That is slow because while network speeds are pretty fast, not fast enough. Always have your code locally to compile. If you can, have a RAM drive, because RAM drives are even faster than SSDs, and it will speed up your performance more. Yeah. All right. Paul says, thanks for your time. Oh, you're welcome, Paul. Victor says, on a Windows machine, it's absolutely no problem. So that could have to do with the network drivers and stuff like that, Victor. I would still not recommend using over a network. I know there's a lot of things changing. So it's got to be a networking issue with Samba drivers on macOS or something like that. I don't know the details, but I would not recommend it. Cool. Glad you enjoyed it. Glad everybody's enjoying it. Good, good. When upgraded, some changes to might be a manifest issue for the one that was saying that their APK Android APK was corrupted after upgrading to 11.2. Good, good. All right, great. Thank you so much, everybody. And I will see you. Oh, if you didn't see, we're doing another webinar here coming up on Delphi Legacy projects with William Meyer. He's got this book here. Hopefully I'm holding that screen. I don't have my webcam up. But that is on Thursday this week. We talk about maintaining and strategies and survival guides for Delphi Legacy projects. Should be great stuff. Not as much as the book as I'd like to be yet, but I'm sure I'll learn some things in that webinar. See y'all then. Take care.